starting our review video for Chapter 9, Section 9, so it's 9.9. Our learning target is to construct and interpret scatter plots. Scatter plots. Well, let's define that term. A scatter plot is a graph that shows the general relationship between two sets of data, an X and a Y. And the line of fit, or the best line of fit, is a line that is very close to most of the data points in a scatter. It is a straight line, and it approximates, or it's the best approximation of the data that's shown. Well, here's a couple examples, 3 examples of scatter plots. What you can see here is there's a plot, an X and a Y, so it plotted out that point, and then all of these represent ordered pairs. But you can see generally that represents an upward slope. All right, so as X increases, so does Y increases. That would be a positive relationship or a positive slope to the line. If you look at this one, the best fit line seems to go down. So as X increases, Y tends to decrease, so that'd be a negative relationship. And here's one where there's no relationship between the data. There appears to be no line that can complete all of those, or link all of those data points. Let's look at some and make some predictions. We're not actually going to graph these. Explain whether a scatter plot for the data, the number of cups of coffee, the number of cups of hot chocolate sold at a concession stand, and the outside temperature might show a positive, a negative, or no relationship. Well, if I've got over here, this is temperature across the bottom. All right, temperature across the bottom, and this is the number of cups sold. I would expect that as the temperature gets higher, the number of cups would go down, which would indicate some kind of a graph that would be downward slope like that, or a negative relationship. All right, as I look at this next one, determine whether scatter plot of the data for the number of cups of lemonade sold at a concession stand, and the outside temperature might show a positive, negative. Well, again, we're going to use temperature across the bottom, and we're going to go the number of cups of lemonade sold. But this time, I think, as the temperature goes up, the likelihood that we're going to sell lemonade would also go up. So I'm predicting that we would have a positive relationship between those scatter points, or between that scatter graph. Explain whether the scatter plot of data for the birthday and the number of sports played might show a positive, negative, or no relationship. Well, the birth date, of course, can be either you're born on the first day of the month, or if there's 31 days in the month, you're born on the last day of the month. And the number of sports could be 0, 1, 2, or higher. I'm predicting that there's no relationship to the scatter points on that, because it doesn't matter whether you're born on the 2nd or the 5th or the 12th as to how many sports you play. The table to the right shows the average and the maximum longevity of various animals in captivity. Make a scatter plot using the data, then draw a line that seems to represent best represent the data. All right, so we're going to put average across the bottom and maximum up the side. We've got a little bit of a scale difference here. I'm going to let, here of course down way down in this corner is my origin. And I'm going to let each number going up the side represent 10 years. So this would be 10, this would be 20, 30, 40, 50, 60, 70, 80, and 90. And going across the side, I need to get to, it looks like a high of 41. So I'm going to let each one be 5. So this would be 5, 10, 15, 20, 25, 30, 35, 40, and 45. Now I'm going to start graphing some of the points here. I can see I've got 12 and 47. So here's 5, 10, 12, and up to 47 would be, say, about right there. And the next one is 25 and 50. So 25 and 50 would be right here. And then 15, 40, 15 and 40. About right here. 8 and 20, so there's 5, 8, and 20 would be just right about there. 35 and 70, so 35 and 70 would be about right here. 40 and 77, 40 and 77 would be about right there. 41 and 61, so just a little bit over on each of these. Be something about right there. And 20 and 54, so 20 and 54 would be right there. Well, if I look at these points, what I'm kind of looking for is a graph that I could draw through those that would approximate all of those points. Well, it looks to me like it's going to be somewhere about like that, somewhere about like that. Okay, maybe a little bit higher than that, but somewhere in that general area. Approximately is number, a mini above is below the graph. All right, well, let's go on and do another one. It says the table to the right shows the average hourly earnings of production workers since 2000. Make a scatter plot using the data, then draw a line that seems to best represent the data. All right. Well, as I can see here, I've got 6 years to plot. So I'm going to go, this would be the year 2000. This would be 2001, 2002, 2003, 4, 5, and 6. And then going up the side here, it goes from just about 11 on up. So I'm going to let this line right here be 11. This will be 1150, 12, 1250, 13, 1350, and $14. All right, so I'm going to start plotting these points. In 2000, it was $11.43, so 1150, just slightly under that. And then in the year 2001, it was $11.82, so it'd be up to about here maybe. And then in year two, it was $12.28, so 12.28, about right there. In year 3, it was 12.78. So in year 3, it was 12.78. There's 12.50, 12.78, just slightly over half. All right. And then it would be 13 and a quarter, 13 and a quarter. I'm sorry, a little bit higher than that. Then 1376, 1350, 1376 would be about there. And 1432, so 14, there's 1450, 1432 would be about right there. If I try to get my best fit on each of those, not a very good line there, but somewhere along that line should be a straight line. If I had a ruler, I could make it much straighter. Okay. Definitely a positive relationship. The graph shows the average and maximum longevity for various animals in captivity. Write an equation for the best fit line of the line fit. It looks to me, I need to know a couple of things about this. It looks like it probably has a y-intercept of about 20. And it looks like it has a slope of, if I go over, you know what, I'm going to do this a little bit different way here. I'm going to say here, I'm going to actually look and calculate the slopes. I've got those 2 points, so I know the point here is 15 on the x, which corresponds to 40, 15 and 40. And then I've got another point up here at 35 and 70. And 70, 35 and 70. So I'm going to find my slope by saying it's the change in the y value, over the change in the x value. So it's 70 minus 40. 70 minus 40 is my change in y, and of course it's 35 minus 15. 70 minus 40 is 30. 35 minus 15 is 20. That's 3 halves is equal to my slope. I need to estimate my y-intercept, and I think I can estimate my y-intercept at about a little bit less here, down into there. Let's call it 17, 17.5. So I'd write my equation then is y is equal to mx plus b. So y is equal to my m, which I found exactly to be 3 over 2 x, plus my b, which I estimated to be 17.5, and that becomes the equation for my line. Okay? The graph shows the average hourly earnings of production workers since 2000. Write an equation for the line of the fit using the points. They tell me what points to use. 0, $11.43, and 5, $13.76. So I'm going to say then that m, or my slope, is equal to y2 minus y1 over x2 minus x1, or that's another way of saying the change in y over the change in x. So 1376 minus 11.43 over the change in x, which would be 5 minus 0. Okay, so I need to do my math on this. I'm going to say 1376, 13.76 minus 11.43. 6 minus 3 is 3. 7 minus 4 is 3. 3 minus 1 is 2. It looks like it went up $2.33, 2.33, and it did that in 5 years. So 2.33 over 5 is my slope, and my y-intercept would be, they told me really, 1143. So y is equal to the slope, which is, well, let's even figure out what 2.33 divided by 5 is on our calculator here. So it's 2.33 divided by 5 years, comes out to be 46 cents, 46.6. So it'd be 0.47, we'll round it off to 0.47 times x, and the y-intercept would be, 1143 plus $11.43 as the starting point. So that becomes my equation for this line. All right, the graph shows the average and the maximum longevity of various animals in captivity. Use the equation, they give me the equation here, to predict the maximum longevity for an animal with an average longevity of 33 years. In other words, 33 years up to this line, but we're going to, instead of use the graph, we're actually going to use the equation. So we're going to say y then is equal to 3 over 2 times 33 years, which is the number we're plugging in for the average, plus 1750, plus 17. All right. Well, I'm going to do a little multiplying here. 3 times 33 is 99 over 2 plus 1750, or 17.5. 99 divided by 2, I'm going to call it, well, we could round it off and call it 50. I guess it would actually be 49.5 plus 17.5. 49.5 plus 17.5 is 67. So the answer would be 67. My drawing was off a little bit here as I went up, but about there. All right. The table to the right shows the average hourly earnings of a production worker since 2000. Use the equation y is equal to 0.466x plus $11.43 to predict the average hourly earnings of a U.S. production workers in 2009. 2009, well, you can see my graph doesn't go to 2009, it goes to 2006. I can still use the equation though. So I can say y then is equal to 0.4666 times x, which in this case is the number of years since 2000, which would be 9 plus $11.43 plus 11.43. Well, 0.466 times 9 I'm going to do on my calculator. And 0.466 times 9 years would show an increase of $4.19.4. So let's go 4.19 plus 11.43. And I'm going to add those together. And I get a total of $15.62.4. 15.62, so their average wage would be somewhere in the vicinity of $15.62. Thank you.